All right, so we kind of ended up, we had our model meshed in the last session. I'm going to go back to our solver interfaces, go back to FEKO. And what I want to do next is I want to discuss kind of the next section. So after we've done our meshing, there are some options for some element manipulation. This is a much more fine-scaled thing. These can be covered in a separate session. But the third, kind of the final overarching topic, apart from geometry cleanup, general meshing, is morphing. And where morphing can come and really help you is it allows us to parameterize changes, right? So morphing, what we're going to do is we're going to change the underlying mesh of our part without changing the IDs and the references which that part holds. So all that we're doing is changing the shape. Okay, so what we're going to be able to do is we're going to be able to kind of make shape variables, and there will be kind of a follow-on session for how we link this with, say, HyperStudy and actually run an optimization. But we have to be able to create the variables first. So that's what we're going to do now. And I'm going to start from a blank session. I still have my airplane open in another HyperWorks session. But what I want to actually do is I want to make a better radome, understanding that the domes that I put on my airplane were pretty dumb. Pretty just normal. But I don't have any geometry. So obviously if you're starting with geometry, you're in a much better spot than me. But give me about 30 seconds. Let me actually make some geometry. Keep in mind the scale of our last part. So I'm going to make this about 100. Click, and then I'll make this about 100. So it'll be a big circle. Okay. I will go ahead and split this solid with a plane. Split this solid with my little saw blade. Hit split. The yellow indicates that that solid is sharing that surface. So escape, escape, escape. I'm going to delete the solids, the solid entity, because I don't really need it. I'm going to delete the surface down here because I don't really need it either. And I guess I'll leave the base surface on. And this is where I'm going to start. So then you're probably thinking, this just looks like exactly the last dumb dome that you made. Well, I understand that. But I want everything to be triangles, so Control Z, undo, and then just make sure trias are what we want. Mesh. Okay. Everything looks like a very beautiful triangle. Is it to me just that this dome looks extra shiny today? Not a lot of shiny on it. It must be sunny outside. Okay, so morph. What? Show me what morph does. Okay. The first thing about morph that I'll show you is morph volumes. These are probably the easiest to understand, the easiest to capture. This will allow you to enclose a selection, whether that's nodes or elements, doesn't matter. So I'm just going to grab all these elements, and it's going to enclose it, right? This is part of just what it does. And what I'm going to do is, morph volumes allow us to split this domain into different areas. They're going to be equal areas, or equal volumes, I guess. It's a morph volume. And I'm just going to go 3 by 3 by 3. Okay. And I'm going to hit enclose. And all this is really doing is it's saying that within this little cube, I'm going to manipulate these elements. Okay, and manipulate them how? Well, we're going to move them. Okay. And kind of like I said, I understand that this is a very dumb dome. So let's make this a little more realistic. So firstly, they're usually not purely domey. I've got something in my throat today. So I'm going to grab all these surfaces, I guess these domain surfaces on the top of my little ball, and I'm going to squish it down. I'm going to go squish, 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 squish. Here's the underlying geometry. I'm actually going to just jump out of here and delete these surfaces because I thought I did this already, but apparently I did not. Okay, so now you kind of see I have more of like a gumdrop looking thing. Okay. Usually these are teardrop shaped. So back here, I'm going to go back and move. I'm going to kind of come and grab maybe this and this face and move these out in Z. So you see we're not remeshing. The change in the element size is just kind of getting averaged around, right? So the element quality is still pretty decent. And then I'm going to come up here. You can move faces, edges, and points. So you have kind of the granularity. If I wanted to, I can come and just pick these 2 points and move these 2 in Z and keep that kind of top face where it is. Or I can just come and select this edge. Again, all of you EM people are probably looking at this and being like, what in the world is he doing? It's a really good question. I'm trying to make a little ray dome, a little teardrop. Bring this in a little bit, bring this one in a little bit. A little bit of an art form. Right? I feel like I've seen a little dome that looks like this. There's something hiding under there. All right, so you got to get the idea, right? Is that I can kind of position this, move this. So these are morph volumes. This is more, I would call this a conceptual design type morphing, right? This is normally not where you're going to start. You're going to have this geometry of the dome that you're interested, at least the general shape of the dome that you're interested in. Maybe there's a few little places that you can tweak. So let's talk about the places that you can tweak. If I look over here, these are entities within the model browser as well. So now that I've actually done all this, I'm just going to delete them because I have, this is kind of where I wanted to start. So I just had to take the long way to get to where I wanted to start. Okay. Now let's talk a little bit more about the other 2 types of morphing. Okay, the first one that we have is Freemorphine, which allows me to literally come and grab a node, if I so choose, and manipulate this node around, right? You're seeing everything move because everything highlighted here is an affected element. So this is this morph area that's kind of automatically chosen for me. And you're also seeing these anchors on the bottom. So this bottom mesh is not moving. It's because it's not included in the manipulation. Okay, so that's something you can do. These things were done automatically. You can obviously turn this off and do these things yourself. So you can move a single node, you can move a path of nodes, you can move faces and edges as well. So if you have those features on your mesh. But something that I think is a little more applicable is probably a proximity, right? So the proximity will take a point and it puts this little buffer zone around it. So now these elements in red are actually what gets affected during this move. So everything outside of the red is not going to change, right? So I can kind of come and add a little bump. Maybe I want another little bump. Oops. Maybe I want another little bump back here. Maybe it's a divot. Okay. Okay. So you're starting to think, okay, I can see this. Maybe the cheeks of this get a little bigger. Maybe the nose gets a little smaller, a little stubbier, right? I'm sure that there are geometric parameters within your CAD system that you can change to do this. But, unfortunately, not all CAD is linked with all solvers, and FEKO doesn't really have a CAD tool that can parametrically change CAD. So my kind of resolution to you is, well, we can essentially parametrically change the mesh in which the CAD is represented. Okay. Something that I didn't show, this free mesh, this free morph can also map to geometry. So I can move nodes or elements to certain targets, whether those targets be surfaces or lines as well. So if I have a new profile, let me quickly come back to geometry. Let me just sketch something real quick that will hopefully make sense to everyone. Okay. So maybe the profile of this nose needs to match this line, right? That's kind of what I'm kind of going for. Okay, so what I actually want to do is I want to move these nodes. If I hold Alt, I can do by path. And I'm going to actually select a target. So that target happens to be a line. Okay. And now when I hit morph, obviously not the prettiest morph in the world, but those nodes have now been projected to that line, right? So I can essentially map an old mesh or old nodes and elements onto new geometry as well, right? So that is another option here as well. And kind of to sum all this up, so everything that I've done up until now has been, you know, interesting, but it's not actually useful, right? Because what we actually need to do in order to actually compare this, like, is this design better than my baseline design? I'm going to say probably not, but I don't actually know that. Is what we need to actually do is we need to make a shape, okay? And a shape is going to be an entity. So I'm going to, this little shape button, I have a plus sign that says create a shape. And what this shape does is this saves these nodal perturbations that I applied to my model. Okay, so this in and of itself is a single shape. Okay, and a shape can technically be a parameter in which we vary in an optimization, right? So this is one shape. We do have the ability to undo all morphs. Okay, so this will take me back to my original design. Once again, maybe let's just come in, do some proximity morphing. I want a few different shapes in which we can compare and contrast, right? So here's just going to be my divot. So I'll save this as a shape. What you could have done is saved every step that I did in this process as its own shape. Okay. So I'm starting to kind of collect these shapes, right? These shapes are here. They're also within the shape button. You do also have the ability to kind of preview, turn these shapes on and off. I would always encourage you to kind of revert all of your morphs to get you back to your kind of baseline design because the shapes can get stacked on top of each other. Okay, so these shapes, once again, they can be stacked on top of each other. Like I said, if I apply both shapes at the same time, they will both be applied. There's also a little preview for like if you wanted an animation of how the little flubber changes. Okay. So the idea behind morphing is that we can take the shape of your radome and we can essentially parameterize different parts of it, pieces of it, separate from geometry, right? So none of this required geometry other than the mapping. If I wanted to do any mapping to geometry, I could do that. But all of this is kind of the ability to optimize this shape, right? And essentially, if we can run FEKO on every iteration of every shape that we have, and we have a tool to do so that will allow you to compare and contrast the different runs, you can kind of see, oh, these shapes have large effects on the effectiveness of the radar cross-section, whatever output you're looking at. And that's how you can kind of optimize these. Okay, so once again, that whole question will be answered in a separate session, but I did want to show the morphing of this part of like a radome. Okay. So that's going to end session 7. The last session will kind of be a wrap up and summary, and you should be well on your way, have enough knowledge to be mostly dangerous at this point.